Okay, for today, very first day, so it's going to be pretty short, and we've got the trig ratios and the Pythagorean theorem. It's not going to be all of those problems, don't worry. I do a subset of those problems. And I want to show you one of my colleagues' course expectations, which I agree with except for one thing. Can you tell from past experience of having me as a math teacher, which of these is wrong for sure? You haven't found it yet? That's kind of sad. Raise your hand if you've seen the part that's wrong. Yes, sir. That's right. Homework is graded. It says it's not graded. It is graded. Homework is graded in my class. Why? Because if I say it's not graded, but you need to do it, I get that. I get that that's like a way for a teacher to like not have to focus as much on homework and things like that. But as soon as a kid hears you don't have to do this, a lot of really smart kids even will say, well, I'm not doing it. And I get that. You've got a lot of things to balance. But I think a combination of me cutting it down to a very reasonable size, you will see that I cut it way back to just a few, and then saying you actually need to do that is the best combination. If the assignment's too big, kids aren't going to do it. If the kids don't feel like it's worth anything, they're not going to do it. Except for the few kids who are like super disciplined and would do it anyways, but there's a few. I need to, it's sort of like sending a mixed message. It's like saying, you guys really shouldn't do drugs. But if you want to, I've got some syringes over here on the table, and you can take some of those as you head out. I feel like that's, I don't want to give a mixed message. I want to say, you should do your homework, and I'm going to grade it. All right, now, I know for some of you are like, that sucks. I don't want to have to do homework. I'm not going to give you that much, and I'm not going to grade it every time. Okay, but it'll keep you feeling like, okay, got to keep homework on the list of high priorities. All right, other highlights here, bring a calculator. It does say take care of restroom visits before class. Well, of course, if you know ahead of time, like you really got to go to the bathroom, go before you get here. But I get, if you need to go, you need to go. As long as you're not doing that every day. If you make it your I'm everyday math going to the bathroom person, we'll probably have to chat about it because I want you to not do it every day, but it'll happen. And you're going to forget your calculator some days. That's okay. Just don't, never bring your calculator. If you need a calculator, I've even bought calculators for kids. It's rare that that's actually the money thing, but when it is, I've even got a kid who used calculator. I'll do that for you, too, if I need to. I get you a calculator if I have to. Okay, but if it's just usually because they haven't said, Mom, would you get me a calculator? All right, you got to get on that. If you've lost it from before, get one. This semester especially, it's called Trig, and you do a lot of it on your calculator. If you don't have the calculator, it's not going to work really well. And the graphing part's important too. So, all right. Be a quality person, wholesale, totally agree with that. And one of the things that I think we all know is that if you have your phone out and are using it in class, that's not being a quality person. We all know that that's not okay. Not in class, not during class. Now at the end, I'll be willing to admit, even on a recording here, that in the last 10 minutes of class, I'm okay with you taking out your phone, as long as it's not during a test. If you want to take out your phone and do whatever you do on your phone, text your friend or something, I'm okay with that in the last 10 minutes, as long as you're getting some homework done too. Get a little homework done, check your messages. I'm okay with that, but it's the last 10 minutes, not when I'm teaching you. Okay, I think, again, I try to be a reasonable person. And I know if it's out and you're texting during class, you're going to miss something important. In the last 10 minutes, I kind of feel like that's your time. I try to make it your time. All right, today you're not going to have a full 10 minutes because it's a math day, which is shorter than usual, and it's our first day. And I'm teaching you some math, so there's not going to be a lot of spare time at the end of the hour. All right, you're going to see this happens a lot. I like this slide. It's a good slide, but I feel like I could do something that would lead up to it and try to connect it to your past, because I don't think you know that this side is cosine and that this side is sine. I don't think you know that, and I want to show you how that came to be. So I'm going to add a slide. So everybody just add a blank page. And then draw a circle. You don't have to use the fancy circle tool. You can if you want. And then make an XY axis that runs through it. You are going to draw this so many times this semester, it's going to be mind-boggling how many times you draw this with a triangle in it. This is just the first of, like, seriously, I bet you draw 400 of these before the end of the semester. Seriously. By the time you've done all your tests and all your homework and practice problems in class. So this is kind of what trig is like. I'm making a triangle strategically there. Why do you, there's certain things about it that I did intentionally. I want you to be able to think openly here. What are some reasons that you think I did it that way versus drawing a triangle, I don't know, over here or something like that? I mean, why did I draw it the way I drew it? Just theorize. I know you don't know for sure. What do you think is special about the way I drew that? Yes, FK. I made one of the angles a right angle. Notice the right triangle thing, yes. Ooh, look at that. You're using, these are the axes, right? And so that means that's the first quadrant, and therefore they're both positive. Keep going. Yep. Awesome. Very good. Anybody want to add anything to that? Yes, sir? The longest side is the radius. Very good. And it's two things. It's the radius, and then think about it. What's the other fancy word for that line? Hypotenuse. This guy. I have a little statue of him. Kid went to Greece. Got this back for me. His hometown. So this is, who do you think? What's his name? His name is Hypotenuse? I don't think so. Pythagoras. Very good. The Pythagorean theorem. All right, so you got everything, but there's a couple things that maybe wouldn't be apparent. How long is that radius? Well, I haven't said, but what if you had to guess? How long do you think I'm going to make it? 1, because it's the easiest number to work with, right? I mean, 0 isn't logical for a side of a triangle, and anything different than 1 is unnecessarily big, so 1's a good side. Then the other sides don't have any logical names. Like I could call that, I don't know, 0.6 or something. I mean, I don't know how long that is. Kind of depends. Or does it? Well, it does depend on some things. But one thing would be how steep I drew the line. What if I'd have gone up here? Do you get that that side would be shorter down there if I'd have drawn it a little differently? All depends on how big the angle is. So maybe I should call that angle something. This angle, put a little theta in there. You're learning so much right now. That theta is the standard for an angle. You're with me? There you go. Stay with me. Write this down if you haven't already. Catch up. All right. That theta is the standard thing we use for an angle. Just like pi, you know, that's a Greek symbol. It means what? Well, it's actually just a Greek letter. We just chose to set it equal to 3.14. This is another Greek letter. We always use that for mystery angles. You know, we could use n if we wanted, but we don't. We use theta. All right. So that one is called the central angle. Take a wild guess why. It's in the center. It's right by the center. Of the three angles, that's the important one. Well, this one's important too, I guess, kind of, because it's a right angle. All right. Last but not least, this distance here, we don't have a good name for it. It's going to be called x. You get why I chose x? It's going in the x direction, right? I bet somebody smart can figure out what I'm going to call this side here. Y. And then, would you agree? Okay, those of you that know me, what does that mean? 12-minute warning. That means we got 12 minutes and class will end. So I got to get through enough to be able to get you a little bit of homework. All right. Would you agree that x squared plus y squared would equal 1 squared? That's kind of an interesting fact, but it doesn't do too much for us yet. Would you agree that if x and y and theta were all put together with trig, like sine, cosine, and tangent, it might have something to do with this thing? Okay, so I'm going back here. So here's my question. think that through. Search your memory banks for what the heck does sine mean again, and tell me what the answer is. What's sine of theta? Who is thinking up a strange word that they were taught back in geometry? Yes, you are correct. SOHCAHTOA. That helps inform us. And then tell me what to do with it, Mr. EL. Okay, I'm going to just, I want you to think before you speak. SOHCAH. Okay. Try it again. What do you think that means? Sine is opposite over hypotenuse. You've got it all right now. You said something different before. All right. Now, this CAH means cosine is, what's A? Adjacent. If you lived in the house adjacent to me, that would mean next door to me. You're drifting. You got to stay with me, or I'm going to put you right here, and then I'll have to, like, wake you up by tapping you on the head or something. Stay with me. Cosine is adjacent over hypotenuse, and then what's the last one? Tangent is opposite over adjacent. All right. Now, if you've got those memorized, awesome. You don't have to write them down. But this is going to help me. If SOHCAHTOA, sine is opposite over hypotenuse, then what's sine? Look in this triangle. Well, it's opposite over hypotenuse. You just said that. So what's the opposite? Opposite from this. Over hypotenuse. What's the hypotenuse? 1. So it's really y over 1. And isn't y over 1 just y? That's why this side is called sine. That's so weird. It's hard to get your head around, but that side is y, isn't it? Then that side length is sine of theta. To get how long this side is, you would take the sine of that angle. That's what sine is. I know, you may not be processing all of this right now. I'm still a math teacher, been doing this for years, and it's still hard for me to contemplate. But let's just follow the same logic for cosine. What's cosine of theta? Well, what's cosine mean again? Ka, which is what? Adjacent over hypotenuse. And then what is the adjacent side? X. Adjacent means like right next door. X over 1, which is just x. Do you see why cosine is x? That's why that bottom thing is cosine. So I want to make sure I tell you why in this class, not just like, hey, that bottom side, that's cosine. Deal with it. I'm trying to show you why it's cosine. All right, and then what's tangent? That is not quite as obvious. Nope, tangent is not the hypotenuse. That's a good guess, because it's the one side we haven't used. Like, don't seem to have a 1 up there, but well, how about this? What does tangent mean? Toa. What does that mean? Opposite over adjacent, and what is the opposite? Y over what is the adjacent. Or if you want to take it to the next level, tangent is really, well, what is y? We just figured it out 2 seconds ago. What's y? Sine over what is x. Right here, cosine. You just learned that tangent is actually sine divided by cosine. All right, that is what trig is like. It's a little bit more obscure. Now, we'll bring it back to the real world because we'll be doing like how high is this flagpole? And we'll set up a right triangle, and you'll figure out problems like that. Here's the kind that I need you to get for today. There are a few classic triangles, and I need you to memorize them. 1, 1, and root 2. Do you guys remember that pattern? If you don't, you got to get it back in your head now. This is a big one for the ACT. Out of the 200 things on the ACT, this is in my top 50 anyway. Top 25% most important things. You got to know the 1, 1, root 2 triangle. By the way, that's a 45, 45, 90 in case you forgot. If you come with nothing else tomorrow, would you please remember these 2 triangles? Take a wild guess with the other one. It's not 45, 45, 90. It's not 60, 60, 60. That's actually kind of what it looks like I drew. Here, I'm going to draw it back. Yes. There's 60 and 30, and take a wild guess what the last one is. 90. Some people would say it 30, 60, 90. And think about it, there's a small, medium, and a large size, right? And the small side is 1. The big side, you know which one the big side is? The longest one, which is the hypotenuse. That one's 2, twice as big as the small side. And then what's the other side? Remember this one? It's as easy as 1, 2, 3, but it's not 3, it's square root of 3. You need to know those ratios. You need to have that memorized. Like, we can't, hold on, sorry. Something went wrong there. Weird. This is happening in some of the other classrooms too. It just wiped out everything I just wrote. That's okay. I can roll with that. I'm going to go to this slide, and I'd like you to go there with me. Just to make sure you're with me, would you please turn your iPads my way so that I can see you are on the right page? All right. Excellent. And would you now, next to this triangle, here's the thing you got to learn for today. You're going to draw what I call the helper triangle. This is a triangle. It's just like this one, except it uses the classic side ratios. You don't have to make it the same exact size, but you have to make it the same general shape. Now we have to label our helper triangle. If this is a 30, this is a 60, that must be a 90. And do you get, I know some side ratios there. The smallest side is 1. The biggest side is 2. What's this last one? Square root of 3. Okay. Now, from these two triangles, we can solve for these two sides. I'm going to call this side C. Do you remember that the hypotenuse is called C? Does that ring a bell? And then the other two sides can be A and B. It doesn't matter which one's which. I'm going to call this one A. Are you with me so far? Almost done here. Now, I need to find A and C. And how am I going to do it? Let's see if you can handle this. C is to 2 like, who can finish that? It's usually a kid or two that can handle this. C is like 2, or C is to 2. Like 10 is to 1. Very good. If you can if that kind of flew easily for you, that's the kind of thing that's on the ACT in the English section, or it could be in the PSAT in the English. Or anyway, yes. Okay, I understand. The next one is A. Let's see if you can do it. You ready? A is to what? Square root of 3. Like, you could say C is to 2, but that's a bad idea. Instead, go 10 is to 1. Why didn't I want to use the C? Because I want 3 numbers in 1 letter. That way I can solve. If you don't know how to solve for that, I'm a little scared for you. You are in honors pre-calc. But I'll remind you, if I want the A alone, I want to clear the fraction out. I want to multiply by the denominator. The kids that had me last semester, I hope you'd remember that I pounded on how do you clear fraction. You multiply by the denominator. So I'm going to multiply by square root of 3, and it fixes it, and A is alone. And the answer is 10 times the square root of 3. And this one, I could cross multiply if you like that better, but I like to multiply by 2 on both sides, and that cancels that, and C is 20. Works really well. You just got to set up little proportions like that. So your homework is just like that. It's 2 questions like that. Are you ready for this? Find the homework by scrolling down until you hit the thing that says assignment day 1. By the way, ignore those recommendations. Those are last year's recommendations for what classes to go to and whatever. Your teacher should have already told you what class they recommended. But if you want to talk to me later, we can. Please first scribble off this 1 here. It's just deceiving. It's actually question 5. This whole thing right here is question 5. All of that is question 5. Yeah, it's got a lot of little parts to it. It just wants you to find all the sides and all the angles. In your class, we have less time than in other classes. I'm just assigning you that one. Now, granted, it's got multiple parts, but that's it. Now, grading it tomorrow, could be graded tomorrow. Am I promising it's graded tomorrow? Nope. It's kind of random. You don't know if it's going to be graded or not, but you need to do it. And generally speaking, I grade more at the beginning to get people into the right habits. All right, so this, I'm going to set up a little helper triangle. And is it a 30, 60, 90? Yes, and this is important. You can't trust the drawing. Have you heard that saying, the drawing is not to scale? Do you see that says 30 right here? Shouldn't that be some other angle? Nope, it says it's 30. It is 30. Drawings are not to scale. You can trust the numbers. You can't trust the pictures. Don't trust your eyes and say, that looks more like a 60 to me. Don't do that. It says it's 30. It's 30. Then this is a 30, 60, 90. And what's across from the 30? Across from 30 is a 1. This side's 2. This side's square root of 3. I've set it all up. All you got to do is the little thing where you go, oh, B is to 2, like, and I'll let you finish that as part of your homework. Your job, figure out all the sides and all the angles. One of the angles is really obvious. But remember, drawings are not to scale. So even if it looks like it's a 30, don't just assume, oh, it must be a 30. Trust only the numbers and the data they give you. I think they're doing that on purpose, is why the first couple problems, the next problem's the same way. This says it's a 45. It doesn't look like a 45 to me, but you can't trust the drawing. It's not to scale. The angles that they say and they write them, you can trust those. If that's a 45, do you get that has to be a 45? Because it'd be 45, 45, and 90. All right. You only have that one question. It'd be pretty pitiful if you couldn't have that done by tomorrow. All right. We got started. You got to know your teacher a little bit. You know where we are. I'll see you all tomorrow. Have a great day.